In this video, we're going to see what exactly is K nearest neighbor. You guys might have heard it. So I'm going to give you a simple analogy that says an example. You just tell me about your friends and I'm going to tell you about you. So if you guys tell me about your friends, I'll tell about you. That's what K nearest neighbor means. If you tell about them, about your neighbors, I'm going to tell about you. And then what exactly is K nearest neighbor? Why do we call it as K nearest neighbor? K nearest neighbor is a powerful classification algorithm used for pattern recognition. That says if you put a pattern up, it's used for recognizing the pattern and it's used for giving the next value. And next, K nearest neighbor stores all the available cases and classified new cases based on the summary. It classifies the measures. It tells what exactly it is. And it's one of the top data mining algorithm. It's one of the top algorithm in the world that's used today and now. A non-parametric lazy learning algorithm. Yes, it's a lazy learning algorithm because you don't need to write much of code, use your brain a lot for thinking, nothing. Just put it, you give it to the computer, it's going to give you the output. And classification approach. How do you classify it? An object is classified by majority votes of their neighbors, for their neighbors. So think you're between two neighborhoods. This is you. You're between two neighborhoods. So you're going to call other neighbors and they're going to see all your features, your address and everything. And then they're going to classify you which layout do you belong to. This layout or do you belong to this layout. That's what it's going to classify. And object is assigned to most common classes. So what is the nearest and the common classes is that one, it will be, you're going to say that it's to this. So which one is your nearest? If you think this side of the layout is nearest to your home, then that layout you belong to. If you think this one, then this layout you belong to. That's how it works. And next you need to measure the distance. For that we have different types. That one you're going to see. Now watch at the green point over here. Let me show you guys. You can watch a green point over here. That's the query point and you need to know which one. Let's think our K value as 4. Let's just think our K value as 4. And now let's take the nearest 4 neighbors of it. Yeah. So let's think the red one as C1 and the blue one as C2. Category 1 and category 2. So how many C1s you have? Category 1 you have 3 and category 2 you have only 1. So what is more? 3 is more. So we take 3 as the neighbor. So you belong to this one. And this is just an example. How to choose your K value. So this is just the explanation of the K value. So suppose you think that you have a lot of large data and one data is less and one type of data is more. So that time you can just think, yeah, that the K value is going to be more. So anyway it's going to be to this, but no, it's not going to be the correct value. So the rule of this is K value should be lesser than the square root of the number of examples. You're going to see how many number of data and everything. And regarding that you're going to check. Feature normalization. This is the classification of KNN. So you have loans in dollars and your age over here. So you think the K value is 4 again. So here you have to take the new values. I mean the nearest 4 values. Okay, nearest 5 values. If you take even number of them, just think that if you take even number of them, even things can come. So then there's going to be a problem. So let's just take the K value as 5. Think the K value as 5. And this is the circle that I took. This is the green point, the query point. So you have 2 default, non-default and 3 default. So it's going to come to default. Let's move on. This is the method for classifying the distance, for knowing the distance. So this is called as the Euclidean method. for classifying the distance, for finding out the distance, Euclidean method. So the distance, the formula for this is, we say distance is equal to the cube root of x1 minus x2 whole cube, whole square, plus y1 minus y2 whole square. So this is the formula needed. And using this you calculate the distance, and most of the time we use this one itself. Most of the time. And this is another type called standard variable. This is another type. This formula is, you take the maximum value amongst all of this and you got minus the minimum value by maximum minus minimum value. You could take the x value minus minimum value divided by maximum value minus minimum value. That's what you're going to take. And now let's see the strengths and weaknesses, like that says the advantages and disadvantages of KNN. So KNN, and the advantage of it is very simple and very initiative. You can just understand it very, very, very easily. So this is the main point, the main advantage of KNN, and that's not there in most of the types. And it can be applied for any data distribution, for any kind of data it can be applied. Good classification if the number is samples is large enough. This can be a disadvantage, this can be an advantage. So it gives a good advantage, it gives a good classification, it gives a good result when the number of samples. Yeah, so first I have imported the necessary libraries and I have read the data. This is the head, and this target class is the value, actual value and the answer of it. So what I am going to do is I'm going to import standard scalar. I'm saying scalar is equal to standard scalar. This is just a variable. And what I'm going to do is I'm going to drop class. I'm going to drop it in the df, but not completely. For now I'm going to drop it. I'm going to fit the target class to say. And then I'm going to say scale feature. This is another variable, scalar.transform df drop target class. So this is also the target class itself. And then we're going to say df feet is equal to pd.data frame scale features dot columns. So this scale features and the columns here. That's it. And we're going to import train test split to split them up. So I'm going to say x train x test, y train y test is equal to x train test split. I'm going to say scale features df dot target class. So I'm going to split this target class. That's what I mean. I'm going to split this target class into x train x test, y test. And I'm going to import k neighbors classifier, that says KNN. So I'm going to say KNN is equal to k neighbors classifier. And then I'm going to fit this x and y train into this KNN, that means k neighbors classifier. And then I'm going to say pred, that means predict is equal to KNN dot predict the x test. So what I'm going to do is I'm going to test this up. I'm going to say x underscore test. I'm going to predict this up so that I know that my computer understood the logic and it's going to put it properly up. It's going to give me the answer right. And then what I have done is I have imported classification report and confusion matrix to know the errors. So I'm going to say print confusion matrix y test predict. The answer that it predicted is this. So both of them are almost similar. So I'm going to say print classification report y test and predict. It's here the precision, recall, F1 score, support, all of them. So I'm going to say error rate. It's basically just an empty list. Error rate is just an empty list, just like this. There's no value inside it. Do not think that if I put this, there's some value inside it and it's empty or something like that. No, it's not at all empty. And then I have the k neighbors classifier. I'm fitting it up, and this is a for loop. I want a range. I want a range from 1 to 39. So if we want it from 1 to 39, we have to write 1 to 40. This last value is not being included. So that's why I have put 1 to 40. And then we have got k neighbors classifier. I'm going to say KNN is equal to k neighbors classifier inside this for, so that this for can know that. And then I'm going to fit this x train and y train inside the KNN. That's it. I'm going to fit it up, and I'm going to say predict underscore I, pred underscore I. So pred underscore I is different, pred is different. I'm going to say pred underscore I is equal to predict the x test, the same value, but inside the for loop is going to be different. I'm going to say error rate dot append, predict I is not equal to y test. I'm going to say I'm gonna append this actually to say. I'm gonna append the predict I and also y test. And then I'm gonna plot to say, to say a bar, to say a line graph. You guys can see its error rate and the k value. Here we have the error rate in the y-axis and the k value in the x-axis. And here we have to see the least error rate. So according to me here the least, okay, sorry. So according to me here the least value is going to be 19. You guys can see here. This is the least one over here, somewhere here. So I have took 19. So I've taken 19 as my k value. So now I hope you guys understood now how to take the k value. I hope you understood now how to take the k value. You have to take the error rate in the graph and you have to check what is the error rate for the k value and you're going to take the k value up. Let's move on. And next you have the k neighbors classifier here. I'm going to say KNN is equal to k neighbors classifier. I'm going to fit the x and y train into KNN. That's because that's already there, but for safety I'm just going to fit it again. And then I'm going to say pred is equal to KNN dot predict the x test. I'm going to predict the x test that we put it into x test, y test, x train and y train. So I'm going to predict this x test and I'm going to print with K19. I'm going to print the confusion matrix and the classification report to know the end value. You can see precision, recall, F1 score and support. The weighted average, micro average, accuracy. So all of them are here and you guys can see here. The error rate and everything. So yeah, now we know what's k nearest neighbors. We know how to import it practically. We know everything about k nearest neighbor. So this topic is basically a bit confusing. You guys, if you guys practice it, you'll get it up. Yeah, you guys know k nearest neighbor now. You know the basics of k nearest neighbor. That's great.